you have a price point that is kind of your break even. Obviously, you want to be above that price point to make money. But there is kind of a checks and balance, because if you get too high priced, then people are like, yeah, it's not worth the money, right? And so if you're going down the road and you see a gas station that has gas at one price and right across the street it's like 25 cents more, you're like, well, this is an easy decision. I'm going to go to this guy that's 25 cents less, because there is this supply and demand that keeps businesses in check. What happens in something like a disaster, like a huge hurricane, is the guy that has the gas can charge whatever he wants. And so that's price gouging. Whereas he's not just charging at his profit margin. He's now saying, I have something that everybody desperately needs because of a disaster. And now I'm going to charge whatever I want because they have to have it. And that's what's protected under our laws, is you cannot price gouge in time of disaster. Now, if supply and demand account for it, so let's say Apple makes, new iPhones and there's a big rush for them, that's not really considered price gouging. If you want to buy something that's not a necessity and you want to pay the price for it, that's supply and demand is allowing it. But when you get above that demand, you got to be careful, because all of a sudden people are going to stop wanting it if it's priced too high. We have questions. Yes. This example right here is actually an example of a system of equations. So you see two equations going on. You see the equation that is the supply equation. This is a linear equation, obviously, there's a line. You see the demand equation, and then you see this equal in price where they meet. The supply meets the demand. This is like the primo price to price something at, because if you get above that, you're going to see your demand going down, right? And if you get below that, you're going to see the supply going down. And so there's this primo little point where your supply and demand kind of meet, and that's usually where your prices are set. But these are two separate equations. One is a supply equation, one is a demand equation, and they cross over, okay? And so this is an example of a system of equations, which is what we're going to be looking at, different systems of equations. And one of the ways we are going to solve systems of equations is by graphing. Where they cross over is where those two have the same exact answer, all right? And so if you look at the first example, they've given us two linear equations. They've given us x plus 2y equals 4, and they've given us 2x minus y equals 3, all right? And so they want to find out what is the solution to this system. What they mean is they want the xy that makes the first and the second one true, okay? So there's going to be a point somewhere, if they cross, where this xy will work for both equations. And the first way we can check to see where that is by graphing. And so you're going to graph these exactly how you would have graphed in the prior section. When it's set up in standard form, it's usually easiest to graph with your intercepts. So I would say, well, for the first one, my x-intercept is just going to be my c value 4 over the number in front of my x, which is a 1. My y-intercept is going to be the 4 over the number in front of the y, which is 2. So I have an x-intercept of 4. I'm going to plot that point right here. I have a y-intercept of 2. I'm going to plot that point. And then I am going to graph it, which means I'm just going to connect those dots. All right, and so if I connect these right here, well, better than that. Better slope. I'm not doing well with this connecting. We'll just do it with a pencil. Connect your two dots, and you're going to see you have the first linear equation. Well, we want to find out where that meets the second linear equation. So we're going to do the same exact thing for this one. My x-intercept, that's going to be 3 over 2. That will not reduce. My y-intercept is going to be 3 over negative 1. And so I'm going to go negative 3 on my y. 3 halves is 1.5. And then I am going to graph this particular one. And there's going to be a point where they cross. Now, if you'll notice, when I graph this, it appears that they cross right there at 2, 1. So if I look, they appear to cross right here. So this is saying the point 2, 1 should work for both equations, all right? I can test it. I can plug in a 2 and a 1. 2 plus 2 equals 4. That is true. I can plug in a 2 and a 1. 4 minus 1 equals 3. That is true. And you can see the 0.21 works for both equations. That is the answer. This first guy, all right? My x and y intercepts are going to be 0 divided by a number. So both my x and y intercepts for this first one are going to give me 0, 0. That does not give me 2 points, by the way. All right? So sometimes it may be easier to graph it with your slope, right? So if I were to take this line right here, might be easier to get it in slope-intercept form. Subtract your 2x over y equals negative 2x plus 0. So you can see that, yes, I started 0, but now I can use my slope to figure out a second point, right? My slope is negative 2 over 1. That means I go down 2 and over 1. So I can get it either from my intercepts or from some point and the slope. Now here's the thing. If your intercepts are both 0, you're going to have to use the slope to find your other point, right? And you didn't have to put it in slope-intercept. Remember, your slope is also negative a over b, right? So I could have just gone straight from here and said negative 2 over 1. I know that I'm going to be at 0, 0 and go down 2 over 1. But either way, you're going to have to use your slope for this guy because both of your intercepts happen at 0, and you have to have at least 2 points to graph your line. All right. The other one, you have 2 separate ones. Your x-intercept is going to be 2 over 3. Your y-intercept is 2 over 2, or 1, right? 2/3, again, that's not an easy one to graph. Now for this one, when I graph it, again, sometimes hard to see where it's going to cross, but this one's going to cross right at 2, or rather negative 2, 4. And you can test it. You can plug in negative 2 and 4 and see if it works. 2 times negative 2 plus 4 equals 0. Yes. 3 times negative 2 plus 2 times negative 4 equals, okay, my little guy's getting in my way. 2 times positive 4, rather. So we have equals 2. Yes, they both work. All right. So there are going to be times when using your intercepts is perfectly fine, 2 points. There are going to be times when, like this, you're going to have to use point and slope. You're going to have to use your 0, 0 is about the only time that'll happen, and use your slope to graph. But you need to be able to graph both lines. Your answer is going to occur where those 2 lines cross. And your answer should look like this. While I'm looking for a graph, I'm also looking that you recognize what the answer is. Okay, so for all of these, you should actually have an XY as your answer. All right, let's try a couple. easily. So you have independent and consistent. Independent and consistent means that they are independent of each other. They are going to cross one time. All right. So they have a solution, but it is one solution. If they are dependent and consistent, they have solutions, but they actually have an infinite number of solutions because they end up being the same exact line. All right. So if they are consistent, that means they are going to have a solution. Independent means they have one solution. Dependent means they are actually the same exact line. And so it's an infinite number of solutions, and your answer is the entire line. You would actually write the line out and box that as your answer. That is the answer. All right. Inconsistent means they do not have a solution. This will only happen when you have parallel lines. Parallel lines never cross. So if they never cross, there is no number that works for both of them. There is no point on the coordinate plane that works for both of them. So consistent means they do have an answer, but independent, they're going to have one answer. Dependent, the entire line will be the answer. Inconsistent means they will not have an answer. They are going to be parallel lines. So you can look at this just from the actual equations. You don't even have to graph them to figure out if it's going to be one of those and which one it is. All right, the easiest way to do this is to get it in slope-intercept form. If it's in slope-intercept form, then you can very quickly see, are they the same line? Are they different lines, but they have different slopes, or do they have the same slope? If they have the same slope, they're parallel, right? Same slope with different intercepts. So the easiest thing to do is to get these in slope-intercept form. So if I were to do this, to get it in slope-intercept form, you need to move your 3x over, right? We have negative y equals negative 3x minus 1, and divide by that negative 1. So we have y equals 3x plus 1. All right? Y equals 3x plus 1. For this one, the second guy, move your 2x over. So we have 3y equals negative 2x minus 8. Divide by the 3. So we get y equals negative 2/3 x minus 8/3. These are clearly different lines, right? And they do not have the same slope, so they're not parallel. So if they are just different lines with different slopes, then this one is going to be this first one, independent, consistent. Different slopes, they are definitely different lines if their slopes are different. All right, let's look at the next one. We're going to move that 9x over. So we have negative 3y equals negative 9x minus 6. Divide by negative 3. We get y equals 3x plus 2. Move the 6 over. We get negative 2y equals negative 6x plus 4. Divide by negative 2. We get y equals 3x minus 2. All right. 3x minus 2. What do you notice about this one? Their slopes are the same, right? Slopes are the same. Their y-intercepts, however, are different. So they're not going to be the same exact line, but they do have the same slope, which means they're parallel. So this guy is going to be inconsistent. This one's going to be inconsistent. All right, inconsistent for that guy. All right, let's look at the next one. Subtract my 3x, we get 6y equals negative 3x plus 9. Divide by 6, we get y equals negative 1/2 x plus 3/2. We're running out of room. We'll scoot this over a little bit. All right, next guy, move the 2x over. We get 4y equals negative 2x plus 6. Divide by 4, we get y equals negative 1/2 x plus 3/2. Those are the same exact line. They have the same slope. They have the same y-intercept. This one is dependent and consistent. And my answer here would be y equals negative 1/2 x plus 3/2. If I were to answer that for what the answer is, the entire line would be your solution because it looks like this middle one right here. So if they have different slopes, you already know you're going to have one answer. If they have the same slope, you have to check. Do they have the same y-intercept? Then that means they're the same line. The whole line is your answer. Do they have different y-intercepts? They're going to be parallel. No solution for that guy. No solution.